Welcome to this explainer on Pandas. Look, if you're working with data in Python, you already know that manipulating and analyzing information efficiently is, well, half the battle. Pandas is absolutely the undisputed heavyweight champion of Python data manipulation. It's literally the most widely used library out there for this exact purpose. Today, we're going to build our knowledge step by step. By the time we're done, you'll understand exactly what this architecture is built on and why it completely transforms how you handle data. But before we actually start building, let's address the elephant in the room. I want to pose a really fundamental question. Why do we even need a specialized library for this, right? Like, why not just stick to plain native Python data structures? After all, Python already gives us lists, and it gives us dictionaries. Why add another whole layer of complexity? Okay, let's dive into this. If you try to use standard Python, say an endless list of dictionaries, sure, it's incredibly flexible, but when you start feeding it thousands or millions of rows, it becomes painfully slow. Plain Python completely lacks vectorized operations. That's the ability to process entire blocks of data all at once without writing those slow manual loops. Now, you could use basic NumPy arrays instead, which are incredibly fast, but they force you to use a single data type across the board. So Pandas is the ultimate solution here. It's built directly on top of NumPy, meaning it inherits all of that lightning-fast performance, but it provides a massive built-in toolset that lets you manipulate complex mixed data without writing endless manual loops. It's the best of both worlds. So, here's our step-by-step blueprint for today. 1. The Pandas advantage. 2. Step 1. Installation. 3. Step 2. The series. 4. Step 3. The data frame. And 5. Preparing for real data. Let's jump right into section 1. The Pandas advantage. Think about what we actually do with data out there in the wild. Almost every single real-world data task, whether you're analyzing retail sales over the last decade, cleaning up incredibly messy human survey results where people inevitably type NA in 5 different ways, or prepping features for a machine learning algorithm, it all starts with one primary goal. You've got to get your data into a tabular structure. You need a format that you can query, filter, and reshape quickly. Pandas exists specifically to give us that structure instantly with all the necessary tools already baked right in. Let's move on to section 2. Step 1. Installation. Now, any good process requires a solid software foundation. So here's the exact step-by-step sequence to get Pandas running in your environment. Step 1, make sure you actually have Python installed on your machine. Pretty crucial. Step 2, open up your command line terminal and install the library. And step 3, at the very top of your Python script, simply import Pandas. With those 3 quick steps complete, your foundational environment is totally ready to go. All right, section 3, step 2, the series. We're going to start with the series. By definition, a series is a one-dimensional labeled array. If you're trying to visualize this, just think of it like a single vertical column. This is us forging the initial foundational bricks of our data structure. It holds your data sequentially, but it has one very special feature that totally sets it apart from a normal list. Now, what's really interesting about this slide is the index. It's not just floating data. Every single piece of data has a corresponding label attached to it. And crucially, those labels do not have to be just sequential numbers. You can use dates, custom strings, or unique identifiers. This attached labeled index is the exact magic that makes Pandas so much more powerful than a plain NumPy array or a basic Python list. It allows for instant targeted lookups. Let's move to and see how this builds in section 4. Step 3, the data frame. Because let's be honest, one column isn't enough to run a business, which brings us to the data frame. A data frame is a two-dimensional labeled table. It looks and feels exactly like a spreadsheet or an SQL table. So the crucial takeaway here is this. Under the hood, a data frame is essentially just a dictionary of those single-column series bricks we just talked about. But the beautiful part is that all of those individual series share the exact same index. They are perfectly aligned row by row. And this brilliantly illustrates exactly what we mean. Look at this tabular structure. We have our shared index on the left. Here it's labeled as row_1, but look across the columns. We've got a string holding apple, an integer of 50, a float of 1.99, a specific calendar date, and even a completely arbitrary Python object. Every single column in our data frame can comfortably hold a completely different data type. Remember how plain NumPy arrays force you into just one data type? The data frame completely removes that restriction. Let's pivot for a second and answer any lingering skeptics. Why is this specific 2D table so revolutionary compared to, say, lists of dictionaries? Well, it's because of the massive standard library of table operations that come built in. Operations that would honestly take you hundreds of lines of code in plain Python are reduced to a single word in Pandas. DataFrames give you fast, vectorized computation across all those rows instantly. You get built-in joins, just like SQL, you get group by operations for quick aggregations, pivoting capabilities, and incredibly robust time series support. You're no longer writing manual slow code to merge datasets. Pandas provides labeled axes, mixed types, and this immense toolkit all in one package. It's a total game changer. Wrapping things up with Section 5, Preparing for Real Data. So we've successfully walked through the entire architectural assembly. We know why Pandas matters, we have our installation steps down, and we deeply understand the series and the data frame. But I want to leave you with a final thought to ponder. We've constructed this pristine, perfect tabular structure, in theory, but out in the wild, you aren't just typing in rows one by one. You have the structure, sure, but how do you actually fill it with thousands or millions of rows of messy real-world data? How do we bridge the gap between a blank data frame and a chaotic CSV, Excel, or JSON file? Well, we are going to tackle exactly how to load that real-world data in our next explainer. See you there.